Hi guys, this is a walkthrough of the Spring Cloud data flow for OpenShift, the 1.1 release. So we're just going to go over a few things, deploy some streams on OpenShift, and just to get a general feel of how it works. The Spring Cloud data flow project, I'm not going to go too much in depth of what it actually is and what it does. You can go read the documentation, and there's a lot of also screencasts, Josh Long, and those kind of things. OpenShift. So OpenShift is basically a container scheduler, builds on Kubernetes. Again, not going to go into too much detail, but you can also find a lot of stuff. We're going to be using OpenShift Origin, which is the open source version. Great. So I'm going to use the reference documentation for the 1.1 release of the OpenShift server. I'm just going to head on over to the Getting Started guide because we're going to basically spin up a local OpenShift environment, deploy some streams to it, and see how it works. Great, so if we go to the Getting Started guide, there's a few ways you can do a local OpenShift cluster. There's OC cluster up, there's all-in-one VM, and mini-shift. So for this cast, we'll do a mini-shift environment because it's really easy to start up. So let's jump into the command line here, and if we quickly start our mini-shift cluster, we're going to use 4 CPUs and about 6 gigs of RAM. Just so we have enough space to kind of deploy everything. Importantly, we're also going to deploy the router. The router exposes services in the OpenShift cluster using resolvable DNS names. Great, so it's up and running now. If we go to the mini shift, we're going to open the console. The OpenShift console is pretty neat. And you can see all the projects that we have now. Projects basically map to namespaces in Kubernetes. They allow you to kind of segregate your apps, different teams, add resource limits to those projects, and so forth. So we're going to create a new project for our little demo called SCDF. If we jump back to the guide, we can we'll log into the OC tool. OC tool is basically the CLI that allows you to work with the OpenShift cluster. It's basically the same as kubectl with just a few extra commands. So we can see all the projects there. What we're going to do now is create our own project. Just copy and paste that, stick it in. And basically, we can go new project. We're going to call it SCDF, and we're going to just give it a quick little description. Great, so that's created. If we go back to our the UI, you can basically see the Spring Cloud Dataflow project has been created there. Nothing inside yet, but we'll soon fix that. So first thing we do is we're going to install the Dataflow server. To do that, probably the easiest way to do that is going to be using the OpenShift templates. Now the templates are a nice thing added in OpenShift, where you can basically template out what kind of resources you want to deploy, and allow you to override some of the properties via parameters and that kind of thing. So there's a few templates available for the OpenShift server. There's just the Dataflow server alone. So that's if you have an existing data source, all that kind of stuff. We're basically going to just use the one with the ephemeral data sources and the Kafka binder. So that's basically MySQL database, no persistent storage, and the Kafka binder just for the binder implementation. Awesome. So to load up all the templates, we're just going to copy and paste this little curl command. It's basically a bash script that just installs all the stuff for us. It's just easier. So that's going off and installing the templates into OpenShift. Great, that's worked. It's done a few other extra things. If you read through the guide, it's adding a service account and that kind of stuff, just so that everything can have the right permissions to do stuff. So now if we go to the add to the project, we'll see there are 4 templates there. As I said, the one we're going to use is the ephemeral Kafka template. What it's going to install is the OpenShift server for Dataflow, MySQL database, Redis for the analytics, and the Duo for Kafka as the binder. Everything is set out here. These are the parameters that you can actually tune, but the default values are fine for what we're going to do. Except for the Maven stuff. So just ignore this for a second. This will come in later, and it's just easier if I do this now than later. So just ignore what I'm doing. Basically, I'm setting up the remote Maven repository so that the data flow server can resolve Maven artifacts from a Maven repository, remote Maven repository. We'll talk about that a bit later. Great, so we click create. That will go and create our resources. So if you want the password to the MySQL database, if you want to go poke around, there it is. Otherwise, let's continue. Okay, we'll dismiss that. And these are basically the pods that are basically scaling up right now. Redis one is up. And we'll give it a sec for the other guys. That's just Kafka dying because it's looking for Zookeeper. Zookeeper up isn't up yet. Okay, it looks like Kafka is up. The Sprinkler data flow server is starting up. It's light blue because the health checks haven't kicked in yet. So we can look at the pod, we can go to the logs, we can see what it's doing. Okay, great, it started. And if we go back, it should be dark blue. So the health checks are running, everything's fine. And we'll just collapse that just to give us a bit more space. Okay, great. So now that Sprinkler data flow server is running, we can open it up. If we go to the dashboard, we'll be using the dashboard to deploy streams. Shell is also available. This one just demos a bit nicer. Okay, great. So first of all, we're gonna install the basic, the ticktock stream. That's basically the one you deploy first. So the bulk import, we're gonna bulk import our apps. So we have to register our stream apps first, and we're gonna use the Kafka binder ones, the Docker-based ones, because OpenShift natively, as Kubernetes does, deploys Docker containers. So we'll go and import those in bulk. Those are there, we can see them now. We can all see them with the Docker resource. Okay, great. Let's go to streams. We can go create stream, and let's create our first stream. We're going to call it ticktock, and we're going to do the time source, and we're going to pipe that to the log sync. So basically that's just going to tick every second, push the message across the binder to the log stream app, which is just going to log it. Click create stream. Nothing extra we want to add, no deployment properties, so we're just going to click deploy streams and create. Now, I've pre-pulled most of the images from Docker Hub. The first time you do this, it might take a while just to kind of pull all the images and that kind of stuff. So just give it a few minutes the first time you do this. Great, so the streams are deployed now. Go back to the definition, we can see it's deploying, and if we head on over to OpenShift, we can see that the 2 pods have been scheduled and they're busy scaling up. So if let's just check on the log. If we go to the logs of the log app, you can see it's busy starting up. Okay, great, the app is started, and we can see it's logging our times. Every second, push from the time source. Okay, awesome. So we can see they're both deployed there, and that's the quintessential ticktock stream deployed to OpenShift. So we'll destroy that for now, because we want to move on to one of the new features added in the 1.1 release of Sprinkler Dataflow for OpenShift, and that was the volume support. So the volume support basically allows you to configure persistent storage for your apps in the stream. For instance, if you'd like to persist something to the file system, that obviously comes in handy. Okay, so what we're going to do is we're going to use our ticktock stream again, but this time we're going to do something a little bit different. So we're going to go ticktock again, time, log, same thing. But this time we're going to use another feature of Sprinkler Dataflow called tap. So we're going to tap the stream, and we're going to call it the ticktock tap. And we are going to tap from the ticktock stream, from the time app, and we are going to pipe the output of the time sync to the file sync. Oops, file sync. Okay, but we haven't actually registered the file sync yet because for some reason it doesn't get imported with a bulk import, so we kind of had to do that ourselves. So if we go to register applications, we can call it the file sync. Let's say sync. And if I just go to my cheat sheet quickly, I'm just going to get the Docker coordinates there, stick them in. It's file sync Kafka. It's going to get it from Docker Hub, and we register that. Okay, so that's there now. If we go back to our stream, fortunately it didn't save that, so we'll just have to do this again. Time log ticktock tap equals, and we're going to tap the stream from the TikTok time app, and we're going to pipe it to the file sync. Cool. So this time it's there. And the file sync takes a few application properties, which you can define. Obviously, where to write the file. Again, I'm just going to copy and paste this from my cheat sheet. So basically, we're saying file sync, please write files to the data TikTok directory. Append the existing file called times. Awesome. So we can click create stream. We're not going to deploy it this time directly because we have to tweak a few values. So if we deploy that, it will be deployed. So I'm just going to grab this. I'll explain it now quick. Go to our definitions. We have two basically streams there. There's the initial TikTok stream and then the tap stream. So that the initial TikTok stream we can deploy. Nothing special with that one. Just give it some time. Alright, so those are deploying. Come back here, we've done that one. So for the TikTok tap stream, what we want is to write the file to persistent storage. So we want to use volumes. So if we click deploy, we have the opportunity to provide some deployment properties. Those are the ones that I copy and pasted. So let's just run through this quick. As usual, when deploying properties, you target the app you want to configure with app dot and the app name, which is file sync. You give it the Spring Cloud deploy OpenShift deployments volumes configuration, and then we define our volume. So our volume is basically going to be called TikTok, and it's going to use the host path volume plugin. Now there's quite a few host path plugin. There's a few volume plugins available in OpenShift, as there is with Kubernetes. Host path is kind of the simple one. It's not really recommended for production use. In fact, it's disabled by default in OpenShift. So what you have to do if you fire up a new minishift instance is use this OC edit SCC restricted. So if I go there quick and open my terminal and pop that in, at the top there, this value would be by default false. You would have to change that to true and actually then restart your minishift instance to get it to actually write to the local or use the host path plugin. Obviously in production you'd use NFS, cluster, Ceph, something like that. Anyway, so we're defining our host path plugin. Yeah, we're basically just pushing it to a path. It's going to go to data TikTok. Then we have our volume mount. So the volume mount basically defines how you're going to use the volumes registered in your system in your container. So again, we target the file sync app, and now we give it the volume mount definition. We just call it the same TikTok, so that name has to match the name of your volume defined. And then we're going to push it to the mount path, which is data TikTok. So this is the same, but this is the path inside the container. And that's basically going to say to the container, when you write a file to this location, data TikTok, it's actually going to be persisted using the host volume plugin, host path volume plugin to data TikTok on the actual node where this part is going to be running. So we click deploy there. Great, and that one is busy being deployed. We can see it spinning up there. And let's go check the logs. Be done soon. So it started up now. Let's go quickly to our terminal. And what we're actually going to do now is we're going to SSH into the little VM that minishift runs, and we're going to go to the data TikTok directory. So that's where we told our file sync to write the files. And if we look there, there's our times file. If we tell this times file, we will see that the time basically it's written, or this file gets appended to every second as the time source pushes out a time. What you can see there, well, maybe for me, is that the time is wrong. It's 6:02 where it's actually 8:02. And that's because this is the UTC time, not in my time zone, which is UTC plus 2, obviously. So we'll just close this off. And that basically gave us kind of how we do kind of the volume support in OpenShift. So with that done, we're going to destroy these streams quick. Okay, there they go. And we'll destroy the next one. Okay, awesome. So the streams are undeployed, destroyed. So I wasn't really happy with that because the time is wrong. I mean, I'd really like it in my own time. So I think we should write a custom app for that. I just happen to have one lying around. It's called the time zone processor. This is the Kafka implementation. Very simple, nothing much to it. Takes in the time as a string, converts it to a configurable time zone. That's about it. So how do we get this custom app into OpenShift or deployed through the Spring Cloud Dataflow server? Well, first we need to make a few changes, because what we need to do is OpenShift is different to Kubernetes in that it adds the capability to build apps. So there's a build config resource available, and that build config resource is quite versatile. You can point it at a GitHub repository, for instance, or you could give it your own custom Docker files and that kind of stuff. So it's quite powerful, and that's actually one of the main distinguishing features of the Spring Cloud Dataflow for OpenShift server, is that it supporting Maven resources as well. Because by default, obviously Kubernetes can't deploy a jar file. That jar file needs to be packaged in a Docker container for it to run, and that's exactly what happens when you use the Maven resource support in OpenShift. You actually reference a Docker file that you provide to the server, and it goes and resolves your Maven artifact from a remote Maven repository, which is hint hint. That's why we did that configuration in the beginning, and it then uses a Docker file to build the container image and then deploy that image. Cool. So we actually need that remote repository that we can push our time zone processor to, which is then going to be resolvable from the Dataflow server. So we're going to use a Nexus repository. You would have seen that the template would have already been added. All we have to do with this one, that the default settings are sane. We just need to give it a actual root host. So the root host is basically the DNS resolvable name that the root gets exposed as. So we're just going to call it Nexus SDF. And then we're just going to create. This will go and create our Nexus repository. Okay, we'll dismiss. Basically what it'll do now is it'll go pull Nexus and it'll start Nexus up. So you can see Nexus is starting there. Light blue indicates that the health checks they're busy running, but they haven't returned a successful result yet. Okay, awesome. Looks like our Nexus part is up. If we click on the root, opens up the Nexus UI, stock standard stuff. And what we're going to do now is we're going to push our custom app into that repository. So open up the terminal here. Just go to my cheat sheet quick. What we're going to do is basically going to run Maven. In our .settings file, we already have the kind of the username and password set up for the repository. The Docker container for Nexus by default comes with the deployment user with the password deployment123. So we can use that, and then we're going to pass it the Nexus URL, which is just a kind of variable we defined in our POM. So we're going to push that. That's going to go build our app, run the test. That's always good. Right, and then it's going to upload it to our Nexus repository. Great, and that's done. So if we go check there, we can see our snapshots, and there it is. There's an app ready waiting to be deployed. So we'll close that, minimize that. So now, as with any new app in Spring Cloud Dataflow, we need to register it. We're going to give it a name. We're going to call it time zone. It's a processor. And we need to give it the coordinates. So I'll use. So notice here that we're not using the Docker resource. We're now using the Maven resource, which is basically the group ID, artifact ID, and version. So we'll register that app, and it's available to us. So let's go create a stream quick. We're going to call it tick zone. We're going to go again, time source. This time we're going to go to the time zone processor. And we're going to pipe that to the log sync. Now the time zone processor needs the time zone that it will convert to, and we'll give it this application property, and we'll do it in my time zone, which is Africa, Johannesburg. Great, so let's create that stream. We won't deploy it yet because by default the Dataflow server for OpenShift needs to know which Docker file to use, and the two kind of major remote repositories or Maven repositories are Artifactory and Nexus. By default, the Artifactory Docker file is used, which it uses a URL specific really to Artifactory. So we need to tell it to use the Nexus repository, and then we can use a deployment property for that, which basically just says your default Docker file, please use the Nexus Docker file, and we click deploy. Great, so you can see the deployment's starting to kick off. Back to front, logs first, and we'll see there we've actually got a build going. So if we open the logs of the build, this is actually the build running in OpenShift to take our custom app, basically download it from the Nexus repository, wrap it in a Docker container. You can see the layers it's already pushed, and then deploy that container into OpenShift. So you can see there it's busy starting up. So you can see the images that it builds. There's the ticktock time zone and the actual image that was built. Go back. There we go. Container's a little slow in scheduling it. Obviously not too many resources on a Minishift cluster. Okay, so everything's deployed. If we go into our time zone app, check the logs, so we can see it's converting the time, right? And it's using the right time zone. So if we go to the log, we should see the right time. And yes, we do 8:13, 8:13. Awesome. Okay, so that brings me to the end of the short little demo of Spring Cloud Dataflow server for OpenShift. Hope you enjoyed it.